A key new concept that we have to consider when we're talking about market power is marginal revenue. Last chapter, when we were talking about perfect competition, we said that marginal revenue was always equal to price. This is because the individual firm in a perfectly competitive market doesn't get to choose their own price. Now we're changing it. We're saying that a monopoly or any firm with some market power has some ability to change their price. Because they have some ability to change their price, we can no longer assume that marginal revenue is equal to price. Now, firms have market power, so the demand curve for their products will have a downward slope. What does this mean for the shape of the marginal revenue curve? All it means is that it's downward sloping just like the demand curve. Before, the marginal revenue curve was equal to price, and so it was horizontal. Now we have the case where, because of the firm's ability to set its own price, it the marginal revenue curve is downward sloping just like the regular demand curve. Marginal revenue is not equal to price for a firm facing a downward sloping demand curve. Why? It's just because when a firm produces more of a product, the price falls for all of its product in the marketplace. This is just sort of the simple intuition of the demand curve. If I'm a monopoly and I start producing more units of a thing, it's not just the price of the new units that I produce that are decreasing, but I also have to lower the price for all of the units that I had produced before. So we end up with a situation where the total revenue change, the marginal revenue, the change in the total revenue that happens when you produce more units, has these two components that are moving in opposite directions. The first component is that when you produce more goods, you have more total revenue just because you have an increase in sales. However, the opposite is happening. There's a decrease in total revenue associated with the fall in market price for all the units that you've already produced. This occurs because we're considering a specific market and decisions aren't sequential. They're all happening at the same time, so firms can't price discriminate. I think this becomes a little more clear when we look at it as a graph. So here I've just plotted a regular demand curve, and we have an initial point x right here, and a second point y. This is x has Q1 and P1, and y has a higher Q2 and a lower P2. So this area A is the revenue lost from increasing output. When we move from X to Y, we increase the output, but because we increase the output, we've also decreased the price. So this area A is all the revenue that's lost by ending up at a lower price. This area B is the revenue that's unchanged, and this area C is the revenue gained from increasing output. Okay, so when a firm with market power tries to make a decision about whether or not to uh, increase production, they have to compare whether or not C is greater than A, whether or not the area that they gain from increasing output is more than the area from their lost revenue, which results from the decreasing price. These two opposite effects on marginal revenue can be shown mathematically. So the additional revenue from selling one more unit at market price, that's just the change in revenue, is equal to the price. The fall in revenue is a little bit more complicated. The change in revenue for the fall from the decrease in the market price is equal to the change in the price over the change in the quantity times the quantity. Combining these effects gives the equation for marginal revenue. So you have that first effect, marginal revenue equals P. So we're just saying that marginal revenue is this plus this. So marginal revenue is P plus the change in P over the change in Q times Q. Okay, so that marginal revenue equation reflects the two sort of countervailing effects from the increasing production and from the decreasing price. Let's consider what the equation means. Like I just said, uh, we have the effect from increasing the price, and we have the effect, or excuse me, we have the effect from decreasing the price, and we have the effect from increasing the quantity. Now, let's assume that this term, the change in P over the change in Q, is a constant. Constant can be any number. It can be 2, it can be 10, it can be 20, it can be whatever you want. But it isn't changing with quantity. It's just a constant. I'll talk a little bit more about this idea of the inverse demand curve in the first figure it out problem. But just for now, assume that P equals A minus B times Q. Okay. When we do an actual problem, we'll substitute in values for A and B. But for now, just assume that like this change in P over change in Q, they're constants. They're just numbers. Okay. So we have our marginal revenue equation. It's just P plus the change in P over the change in Q times Q. We're going to substitute in for P. So we have P equals A minus BQ. So we're substituting that in here. We have A minus BQ plus the change in P over the change in Q times Q. We're going to do one more substitution. I said that this change in P over change in Q is constant. Well, because it's constant, we're going to substitute in negative B. Okay. You're probably wondering, why is it negative B? Well, remember, when we're talking about the change in P over the change in Q, the change in P is going to be a decrease in P. So that change in P is going to be a negative number. And the change in Q, you're increasing Q, so that's going to be a positive number. So the whole term, this change in P over change in Q, will be a negative number. So we're going to assume that this term is equal to B, and it's negative, so we say it's negative B. And then just simplifying this whole thing, we can say that marginal revenue equals A minus 2B times Q. If that's a little confusing, don't worry too much about it. The first figure it out problem for this chapter gets into it with a practical example with some numbers. So hopefully it won't be unclear for too much longer.